Okay, so for this video, we're just going to briefly go over a couple of algebra concepts that are going to relate to parallel. This whole chapter is about parallel lines, transversals, angles they form, etc. So we're looking at things in the Cartesian plane or the xy plane. This is just a quick refresher over slope and equations of lines. We've already touched over this at the very beginning of the year. But just to remember, slope of a line, it's the ratio of vertical change to horizontal change. Another way to say that is rise over run. The way we find that is we figure out how much the y values have changed, and we divide by how much the x values have changed. So this is our slope formula, y2 minus y1 over x2 minus x1. Make sure you remember that. Make sure you know how to calculate it, because we are going to use it quite a bit. A couple of big ideas having to do with slope. Big idea number one, whenever we're working with parallel lines, they're always going to have the same slope. So if you have equations of lines and you can identify their slope, you can determine if those lines are parallel or not. If they are, then we know that when they have a transversal, all of the angle pair properties that we saw in the last section are going to be true, like alternate interior are congruent, corresponding congruent, etc. So that's the first big idea. Now, if your lines are not parallel, and if they meet at a right angle, they're going to have negative reciprocal slopes. So for example, let's say that you have a line that has a slope, I'll say m1 for slope 1. We use m for our slope. Suppose that the slope of one of your lines is like 2/3. Well, if you have a line perpendicular to a line having a slope of 2/3, its slope, I'll call it m2, would be the reciprocal and then the opposite sign. So notice when you multiply those together, you're going to get -1. So perpendicular lines always have negative reciprocal slopes. Another thing that we're going to see, horizontal lines, they have a slope of 0. And you'll figure that out real quick when you try to calculate their slope. In that slope formula, you're going to get a 0 in that numerator. And then vertical lines have no slope. So there's a difference between a slope of 0 and having no slope. Let's see real quick what that difference is. So on the left side here, I've got a horizontal line, and then on the right, I've got a vertical line. This horizontal line, if I try to calculate the slope, so rise over run, y2 minus y1 divided by x2 minus x1, the order actually doesn't matter just as long as you keep the same order. So if I'm choosing this as my second point, I got to make sure I keep using that x2 and y2. So if you calculate that, 0 divided by 4, you get 0. Because remember, 0 divided by whatever is okay, you always get 0. However, for this vertical line, if I try to do my slope calculation, y2 minus y1 over x2 minus x1, we get a problem because we get a 0 in the denominator. That is no good. We cannot divide by 0. So that's why we say this has no slope. Its slope is undefined. It doesn't have any slope, versus this slope has a value of 0. So 0 and undefined aren't quite the same thing. So that's all some refresher from Algebra 1 having to do with slope. Another thing we're going to do in this class next, we're going to take a look at equations of lines. So you all should be really familiar with slope-intercept form of a line, y equals mx plus b. M is that same slope that we calculated, y2 minus y1 over x2 minus x1. The benefit of this equation, if we have the equation, we can spot what the slope and the y-intercept are. So if I have y equals 2/5 x minus 4, I can see that my slope is 2/5 and my y-intercept is -4. All right. Now, if we're trying to make the equation of a line, which is really often the case, you kind of need the y-intercept and that slope. If you don't have the y-intercept, you can solve for it. But if you have another point, say the point, 2 comma 1, then it's a lot more convenient to use something called point slope form. So these two here, you can actually get from one to the other pretty quickly. But for point slope, this is one that is kind of my go-to, and I highly recommend you adopt that same mentality because it's usually a little bit easier to work with. For example, let's say that I know I have a slope of, oh, I don't know, -6. So let's say they're describing to me, find the equation of a line that has a slope of -6 and goes through the point, how about 5 minus 2? So here, this is not my y-intercept. It's not my y-intercept because to be the y-intercept, I should have a 0 for my x value. I don't. So I can just plug in, this is like my x1 and my y1. So y minus -2 equals slope x minus 5. So this right here would be an equation of that line with that slope of -6 and passing through that point. Now, if you needed to take this equation and turn it into slope-intercept, you could do that real quick. Just distribute in, subtract your 2 on both sides, and then voila, you have it. So that's pretty much all you need to know for 3.3 and 3.4. Again, this is all some algebra review that we've already seen before.